Welcome to FMA 0146 Basic Mathematics.
In this video, we are going to discuss some of the questions about chapter 2.1 equations. In this chapter, we have three different types of equations. The first one is surd, the second one is indices, and then the third one is logarithm. But for the logarithm and the indices, we can interchange the method. It depends on the type, for the questions. Okay, so let us look at question 1. We have a surd 6 plus 2x minus x equals to 3. Over here, the equations is involving one surd. So, and our aim is regardless one surd or two surd, our method is always started by isolating one surd at one side. So, I will try to isolate my surd 6 plus 2x on the left hand side. So, I will shift my x to the right hand side. And then, after I isolated the surd, so what I'm going to do is I squaring both sides. So the left hand side is 6 plus 2x. The right hand side I use a plus b square is a square plus b square plus 2ab. So I have a 9 plus x square plus 6x, and rearrange everything. X square plus 4x, then plus 3 equals to 0. By calculator, okay, my x is -1 and my x is -3. So, because of my surd, there are someone else except the one in the surd. So, what I need to do, I need to do the checking. How are we going to do the checking? By substituting x equals to -1 into the original question, surd 6 plus 2 multiplied -1 minus -1 actually equals to 3. So this one is true. And when my x equals to -3, I substitute into my original question. 6 plus 2 minus 3 minus -3 also equals to 3. This one also true. So my final answer is x equals to -1, or my x is -3. Now we look at this question number 2. I have two surd, okay, and these two surd are at the same side. So as I said earlier, that we want our strategy are always the same. That is, isolated one surd on one side, the rest shifted to the other side. So I just keep the first surd 2x plus 3. Then I shifted the other one, 5 minus 7 minus x. And the technique are also the same, just squaring both sides. My left hand side is 2x plus 3. My right hand side becomes 25 plus 7 minus x, then minus 10 square root of 7 minus x. And I just shifted this one to the other side. Okay, so I have a 10 square root 7 minus x equals to 25 plus 7 plus 3 minus x minus 2x. So, okay, this is not plus 3. This one is a minus 3. So, we take 25 plus 7 minus 3 actually is 29. So, my right hand side is 29 minus 3x, 10 square root 7 minus x. Why I didn't divide by 10? Because I don't want to have a fraction. So I just keep my 10 on the left hand side. Square. So this one is 100. 7 minus x. The right hand side will become 29 square. Excuse me. Plus 9x square minus 3 times 2 times 29x. So, by the end of the day, the right hand side is 9x squared minus 29 multiplied 6 is -174 And then over here is 29 square is 841. And don't forget whatever in the left hand side, we shifted to the other side. Okay, plus 848. So minus 700 and then plus 100. So finally, we have 9x squared minus 74x plus 1410, and use the calculator to provide our the roots for us. So this one, what we're going to key in is a equals to 9, b equals to negative 74, and c is equals to 141. And by the calculator, they give us the answer is 47 over 9 or 3. Okay, so by anyhow, so what we do is we just substitute the value of these two inside to verify. Don't forget to do the checking. Okay, now let us look at the question number 3. We have 4-2x minus 4x equals to 6. The strategy for the indices is we try to change them into the similar base if possible. But the problem over here, we have one beloved 6. If you look at here, if you have a 6, you know that is by any chance it cannot be changed to the base 2 itself or base 4. So what we need to, then we know that we learn another one is we try to group them into the similar shape. That is, over here I have a 4 power of 2x. So I can rewrite in the form of 4x multiplied 2. Okay, this one is following a n bracket n actually is a n bracket m. So now for 2x I write as a 4x2. So I just let my p equals to 4 power of x. So I have 4 2x actually is 4 x power of multiplied 2 also as a p square. So now this question is already become p square minus p minus 6 I move it to the other side equals to 0. So I have my p minus 3, p plus 2 excuse me equals to 0. So my p equals to 3, and my p cannot be negative 2, rejected. Why? Because indices is impossible negative value. So what is my p? Don't forget is a 4, x equals to 3. So what is my x? So we just take log left hand side. 4x equals to log 3. So x actually is log 3 divided by log 4. You can get the answer by pressing the calculator. And for the indices, we no need to substitute inside to verify our answer. Okay, then we have the second. This is the second question for the indices. 9x, 3x plus 2 equals to 10. And this one, 10, we also know that is we cannot change it to the base 3 or base 9. So what we need to do is we look at it. We have a 9x, we have a 3x. So now we try to change our everything to the shape 3x. Okay, so whoever not fit in into 3x, we will do some plastic surgery on it to make it to look like 3x. Okay, why not 3x plus 2? Actually, you can try, but the thing is it will be quite troublesome. So that's why we choose the simplest is 3x. Okay, maybe some of you say, ask, how you want to identify what to change? Okay, so over here we only have 2% with x. The first one is 9 power of x. Then the second one is 3x plus 2. So which one is 9x? 3x plus 2, maybe you say that is change it to 9x is simpler, but the thing is we already learned that is if possible anything we change it to a smaller value, and please to avoid the fraction. Okay, so that's why we will try to make our 9 to look like a 3, but because of 3x plus 2 also not a norm to us, we always see is 3x, so we try to do some plastic surgery on our 3x plus 2. Okay, so now we have 3x plus 2 by the formula. Okay, pm plus n actually is pm multiplied pn, so my 3m plus 2 I can change it to 3x multiplied 3 power of 2, or we can say that is 9 multiplied 3x. And then we have our beloved 9x. So remember, actually 9 is 3 power of 2 x, and change the form because I only want 3x, so the 2 I keep outside, so I have 3x power of 2. So now these questions, I already changed it to become 3x power of 2 plus 9 3x equals to 10, and let our p equals to 3x. So I have a p squared plus 9p minus 10 equals to 0. So I'm going to have a p minus 10, p plus 10, p minus 1 equals to 0. So my p actually is only 1 because p cannot be negative 10, rejected, as I said at the question earlier. Indices have no negative. So what is my p? P actually is 3x equals to 1, or actually is 3 power of 0. So indicating my x actually is 0. Okay, so this one actually should be 0. Okay, now let us look at the questions involving logarithm. Logarithm also like our indices, that is we should look at our base first. When the question with a different base, then we should change them into the similar base. I have base 2, I have base k. Okay, then you can change it to the similar base here. One is 2, another one is k. Or maybe you say that, can I change to base 10, base e, and so on? You can. But the thing is the working will be slightly more complicated because the base are not the norm, because everything your working will become messier actually. So that's why to avoid some careless mistake, so you can either change to base 2 or change to the base k, but the easiest is always change to base 2 because that is more normal. Okay, so now since the first one, okay, so how to change base when you have a log? Base A, B. If you want to change, you can change to base C, any base you want, and copy back the B and divided by the A. And remember, both must be similar base. Okay, so now this question we want to change to base 2, so keep as a base 2. And this one, when I want to change to base 2, I copy back 4, and the denominator I change it to base 2, k, and 3, don't touch it. And after that, 2, okay, 2, log 4 actually is log 2, 2, 2, actually this one is equals to 2. And now, if you notice here, okay, this one is here, okay. Okay, so now there is one more problems over here. Okay, you have a k have a power of 2, and this is log k. So now we know that is log pq actually is q log p. So this one I can change to 2 log 2k minus 2 over log 2k plus 3 equals to 0, and let our log 2k equals to p. So I have a 2p minus 2 over p plus 3 equals to 0. So I have a 2p squared plus 3p minus 2 equals to 0. So by the calculator, p equals to, okay, let us check. By the calculator, we key in a as 2, b as 3, and c as negative 2. So my p is 1 over 2 or negative 2. Okay, so now because this question is indices, this question is logarithm, not indices, so negative value for this one is still accepted. So what we do is, if p equals to half, or our log 2k actually is half, so k actually is 1 over 2 power of 2, this one bring up, so it's 1 over 4. And then the second one is, if p equals to negative 2, log 2k is negative 2, this one bring here, k equals to 2 power of negative 2. Okay, so this one is 1 over 4, right? Okay, 2 power, sorry, this one I make the mistake. Okay, this is 2 power of 1 over 2. So this one is square root of 2. Sorry, this one. And this one bring here, this one is 1 over 4. And if you want, you can do the checking. Okay, now we look at the question 6. And this also a logarithm questions. And over here, we are very happy. The base are the same, but the 3 without have without a base. So this question, you have two different ways to look at this one. The first one, we implementing the logarithm property, log p minus log q equals to log p over q. So I can combine log y divided by y minus 3 equals to 3, and this one is base 2, and I bring my 2 to the other side, is y minus 3 equals to 2 power of 3. So I have a y equals to 8 multiply x minus 3, so I have a 7y equals to 24. Okay, correct? Okay, so then my y actually is 24 over 7. Or if you don't want to bring this one up, we are doing the same thing, log base 2 y minus 3. Actually, what is 3? 3 from log a equals to 1. So log 2 equals to 1. So when you want to have a log 2 multiplied 3, which is 3. So actually, we bring out here, actually we have a log 2 power 2 power of 3. So you can compare y minus 3 actually is equals to 8. So it's same thing over here. Okay. And then let us look at the question 7. If we look at here, we have one is base 2, another one is base 4. So change them into the same base. The left hand side, log 2y. The right hand side, base 2, we copy the 1 y plus 20 and divided by log 2 4. This one actually is 2. Okay, log 2 4 actually is log 2 power of 2. So this one is 1, so this one is 2. Then I have a 2 log 2y equals to log 2y minus 20. If you want, you can shift this one to the other side. But what we are going to do, I just bring my 2 to become the power. I have a log 2, y power of 2 equals to log 2 y plus 20. So I compare the logarithm. So my y2 equals to y plus 20 and y2 minus y minus 20 equals to 0. And using the calculator, Okay, so by using the calculator, what we're going to get is, by keying A equals to 1, B equals to -1, C equals to -20. So I will get my Y equals to 5 and my Y equals to -4. But the problem is, that's why we said that we always want to do the checking. Log 5 equals to log 5 and 25. Okay, this one no problem. But the thing is, log 2, okay, sorry, this is 2. Okay, log 2 -4. This one is invalid because logarithm cannot have a negative as an input. Okay, it must be positive. And this question is the last question for this exercise. If you need more exercise, please look at your module. Thank you.